Welcome to a new episode of Sleep Journey Through Forgotten Worlds, your podcast for relaxing, letting go, and learning. Are you already familiar with our other Sleep Journey series, like Sleep Journey Through the Universe? Today, I'm taking you on a journey to one of the most mysterious places on our planet. We are heading into the Bermuda Triangle, that legendary region in the Western Atlantic that has captured people's imaginations for centuries. Lean back, close your eyes, and let's dive together into the depths of this fascinating ocean region. The Bermuda Triangle spans an area of about 1.5 to 4 million square kilometers, depending on which definition you use. The classic boundary forms a triangle between the Bermuda Islands in the north, Puerto Rico in the south, and Miami, Florida in the west. Imagine floating over this endless expanse of water, which is larger than the entire Mediterranean Sea. Below you stretches the deep blue Atlantic, crisscrossed by warm currents and populated by countless marine creatures. The history of the Bermuda Triangle as a mystery doesn't begin in modern times, as many believe, but goes way back. Even Christopher Columbus reported strange observations in this region on his first voyage in 1492. In his logbook, he noted that the compass showed unusual deviations and that he saw strange lights on the horizon. These records are the first documented reports of unexplained phenomena in this area. Imagine the sailors back then, equipped with primitive navigation instruments, sailing out into the vast ocean, always heading toward the unknown. The term Bermuda Triangle itself was only coined in 1964 by the American author Vincent Gaddis. In an article for Argosy magazine, he used this name for the first time and described a series of mysterious incidents. The name stuck and became world famous through the book The Bermuda Triangle by Charles Berlitz in 1974. Berlitz's work sold millions of copies and cemented the region's reputation as the most dangerous waters in the world. But what really makes this area so special? Let's take a look at the scientific facts. The Bermuda Triangle lies in one of the busiest shipping lanes in the world. Every day, hundreds of ships and planes cross this area. The region connects major ports on the US East Coast with the Caribbean and Europe. This high traffic density alone statistically increases the likelihood of accidents. The ocean depth in this region varies dramatically. While some areas are only a few hundred meters deep, others drop off abruptly to depths of over 8,000 meters. The Puerto Rico Trench, which stretches south of the triangle, reaches a maximum depth of 8,648 meters, making it one of the deepest points in the Atlantic. These extreme depth differences create complex current patterns and, in the event of shipwrecks, can cause wrecks to quickly slide into unreachable depths where they are never found. A particularly fascinating phenomenon in this region is the presence of methane hydrate deposits on the seafloor. Methane hydrate is an ice-like substance consisting of methane gas and water that remains stable on the seafloor under high pressure and low temperatures. Scientists have discovered extensive deposits of it in the Bermuda Triangle in recent decades. Under certain conditions, these hydrates can become unstable and release large amounts of methane gas. Imagine huge gas bubbles suddenly rising from the seafloor, thousands of meters below the surface. These bubbles dramatically reduce the density of the water. A ship that is normally supported by the buoyancy of the water can lose its footing in such frothy water and sink within seconds. Experiments have shown that even large ships can lose their buoyancy in water heavily saturated with gas. The gas rises in massive columns, breaking through the water's surface and dispersing into the atmosphere. The Gulf Stream current also plays a central role in the dynamics of the Bermuda Triangle. This powerful ocean current transports about 150 million cubic meters of warm water per second through the region daily. That is equivalent to 150 times the volume of all the world's rivers combined. The Gulf Stream moves through the area at speeds of up to 9 kilometers per hour and can transport shipwrecks, debris, or even drifting objects hundreds of kilometers away in a very short time. This explains why no wreckage was found in many accidents. They were simply carried away before rescue teams arrived. The weather in the Bermuda Triangle is notorious for its unpredictability. The region lies within the path of tropical storms that develop every year between June and November. These hurricanes can develop from harmless low-pressure areas within hours and reach wind speeds of over 250 kilometers per hour. The waves in such storms tower into mountains 15 meters high and more. Even modern ships can run into distress in such conditions. Another meteorological phenomenon is the so-called white squalls or microbursts. These sudden, extremely strong downdrafts occur when cold air from high thunderclouds abruptly plunges downward. Hitting the ocean's surface at speeds of over 270 kilometers per hour, these winds can crash planes on final approach or capsize ships. The tricky part: these squalls are barely predictable on radar and can arise from a clear sky within seconds. The magnetic anomalies that Columbus reported are actually real, though not supernatural. The Bermuda Triangle is one of the few places on Earth where the magnetic declination between magnetic and geographic north is nearly zero. This means that a compass here points exactly north without any correction. Historically, this caused confusion for navigators who were used to correcting their compasses for the expected deviation. An incorrect course correction could throw a ship many kilometers off its intended path. Additionally, local magnetic anomalies caused by iron ore deposits in the seafloor can further affect compasses. Modern GPS systems have largely solved this problem, but for navigation in earlier centuries, this was a real challenge. Let's now look at some of the most famous incidents that gave the Bermuda Triangle its mysterious reputation. The most famous case is undoubtedly the disappearance of Flight 19. On December 5, 1945, 5 U.S. Navy TBM Avenger torpedo bombers took off on a routine training flight from Naval Air Station Fort Lauderdale in Florida. The planes were manned by experienced crews, and weather conditions seemed acceptable. At 3:45 p.m., flight leader Lieutenant Charles Taylor reported over the radio that both of his compasses had failed, and he didn't know where they were. In the transmissions that followed, growing confusion could be heard. Taylor believed they were flying over the Florida Keys, but they were actually over the Bahamas. The radio signals grew weaker and weaker. At 7:04 p.m., contact was lost for good. All 5 planes with a total of 14 crewed Keys, but they were actually over the Bahamas. The radio signals grew weaker and weaker. At 7:04 p.m., contact was lost for good. All 5 planes, with a total of 14 crew members, vanished without a trace. What makes the story even more mysterious, a PBM Mariner rescue plane with a crew of 13 sent out to search for Flight 19 also disappeared. According to records, an explosion was observed at sea 23 minutes after takeoff. A passing merchant ship reported burning debris on the water. But to this day, no definitive wreckage has been found. However, the PBM Mariner was known for being prone to fuel leaks and was called flying gas tanks by pilots due to the fire hazard. Another puzzling case is the disappearance of the USS Cyclops in 1918. This 542-foot-long U.S. Navy collier was en route from Barbados to Baltimore, with 309 people on board. The ship was carrying 11,000 tons of manganese ore. It sailed from Barbados on March 4, 1918, and was never seen again. There was no distress signal, no debris, no survivors. To this day, this remains the largest loss of life in U.S. Navy history outside of combat. Scientific analyses suggest that the ship may have been overloaded. Manganese ore is extremely heavy, and the structural integrity of the USS Cyclops had already been questionable before the voyage. A sudden structural failure in rough seas could have sunk the ship within minutes, leaving no time for a distress call. The great depth of the ocean in this area has prevented the wreck from ever being found. The disappearance of the Star Tiger and Star Ariel, 2 British commercial airliners, deepens the mystery further. The Star Tiger vanished on January 30, 1948, on a flight from the Azores to Bermuda with 31 people on board. The last radio report came at 3:15 a.m., reporting a routine flight with good visibility. About an hour later, when the plane should have landed in Bermuda, it remained missing. Exactly 1 year later, on January 17, 1949, the identical Star Ariel disappeared on a flight from Bermuda to Kingston, Jamaica. 20 people were on board. The last radio signal came 50 minutes after takeoff, again reporting good weather and normal flight operations. Both planes vanished without a trace, with no distress call and no debris. Imagine these large planes flying through the clear night sky over the Atlantic. The stars are reflected in the dark water below them. The passengers are sleeping or reading. The crew is monitoring the instruments. Everything is calm, routine, and then simply nothing. Silence, as if the ocean had swallowed them up. Investigations into both cases yielded no definitive cause, but speculated about possible technical defects, fuel exhaustion due to headwinds, or sudden weather changes. The Tudor 4, the aircraft type of both planes, did indeed have issues with fuel gauges and heating systems, which could become critical at freezing flight altitudes. But speculated about possible technical defects, fuel exhaustion due to headwinds or sudden weather changes. The Tudor 4, the aircraft type of both planes, did indeed have issues with fuel gauges and heating systems, which could become critical at freezing flight altitudes. But despite all these spooky stories, a sober statistical analysis shows a very different picture. In fact, the accident rate in the Bermuda Triangle is no higher than in other comparably busy ocean areas. The U.S. Coast Guard, which keeps detailed records of maritime incidents, confirms this. The insurance company Lloyd's of London, which has been insuring ships for centuries, does not charge higher premiums for voyages through the Bermuda Triangle. That would be unthinkable if the region were actually more dangerous than other waters. The National Transportation Safety Board and the U.S. Navy have stated in detailed reports that most incidents in the Bermuda Triangle can be attributed to human error, mechanical failure, sudden weather changes, or a combination of these factors. Modern navigation systems, improved weather forecasting, and safety standards have drastically reduced the number of accidents. It is the combination of natural hazards that makes the Bermuda Triangle a challenging but not supernaturally dangerous area. The extreme water depths, unpredictable storms, strong currents, potential methane releases, and historical navigation difficulties combine to create a complex hazard potential. But all of this can be explained scientifically. Human psychology plays a big role in the mystification of the Bermuda Triangle. We are fascinated by mysteries, by the unexplained. Stories of vanished ships and planes continue to be told, embellished, and dramatized. Incidents that occurred outside the triangle are sometimes retroactively moved to the region to feed the legend. Cases that have been solved are often ignored in popular accounts. Charles Berlitz, whose book made the Bermuda Triangle world famous, was later criticized by journalists and scientists for omitting facts, distorting reports, and presenting solved cases as unexplained. Still, his book had a huge cultural impact and shaped the image of the Bermuda Triangle to this day. Let's now linger in silence for a moment and imagine what it's really like to travel through this region. Modern cruise ships cross the Bermuda Triangle regularly. Thousands of passengers enjoy the sun on deck while the deep blue Atlantic glides by beneath them. Planes cross the area every minute. For the vast majority, it is a completely uneventful passage. The crystal-clear water of the Bermuda Triangle is home to an extraordinary variety of marine life. Coral reefs line the shallower areas around Bermuda and the Bahamas. These reefs are among the northernmost in the world and host over 300 species of fish, from colorful parrotfish to majestic rays. In the deeper waters, whales make their way, humpback whales and sperm whales navigating through the warm currents. The Bermuda Islands themselves are of volcanic origin, formed about 100 million years ago. The characteristic pink beaches owe their color to tiny red organisms that live on the coral reefs. The clear, turquoise water around the islands offers visibility of up to 60 meters, a paradise for divers. In recent years, marine scientists have studied the Bermuda Triangle intensively. Using state-of-the-art sonar technology, they map the seafloor, discover sunken ships from different eras, and document geological features. Some of these wrecks date back to the time of the Spanish conquistadors, laden with treasures from the New World. Others are modern freighters that sank in storms. This underwater landscape tells stories of human adventure, trade, and discovery, but also of the dangers the sea holds. Each wreck is a testament to its time, a snapshot from the history of seafaring. Archaeologists and historians are working to make these silent witnesses speak, to unlock their secrets. Scientific exploration of the Bermuda Triangle has taught us that the true mysteries lie not in supernatural forces, but in the complex natural processes of our planet. The interactions between ocean, atmosphere, and seafloor are so diverse and sometimes extreme that they will keep us busy for a long time to come. The study of methane hydrate deposits, for example, is important not only for understanding the Bermuda Triangle, but also for global issues. These hydrates store vast amounts of carbon. Scientists estimate that there is more carbon stored in the form of methane hydrates on the global seafloor than in all fossil fuel deposits combined. If the oceans warm due to climate change, these hydrates could become unstable and release large amounts of methane, a potent greenhouse gas. The Bermuda Triangle thus serves as a natural laboratory for processes that affect the entire planet. The flow patterns of the Gulf Stream, which run through the Bermuda Triangle, are also of global significance. The Gulf Stream is part of the Atlantic Meridional Overturning Circulation, a gigantic conveyor belt that transports heat from the tropics to the North Atlantic. This system fundamentally influences the climate in Europe and North America. Studies show that the Gulf Stream is weakening, possibly as a result of melting ice sheets in Greenland. Observing these changes in the Bermuda Triangle helps scientists better understand and predict global climate changes. The coral reefs in the region, like those everywhere else in the world, are threatened by rising water temperatures and ocean acidification. These ecosystems, which have developed over thousands of years, are sensitive indicators of the health of our oceans. Protecting them is not just a regional task, but a global one. Coral reefs host about 25% of all marine species, even though they cover less than 1% of the ocean surface. Their loss would be an ecological catastrophe. As you listen to this sleep journey, remember that the true meaning of the Bermuda Triangle lies not in its mysteries, but in what it teaches us about our planet. It reminds us of how powerful and unpredictable the forces of nature can be. It shows us how important scientific understanding is to separate myth from reality. And it warns us of how precious and vulnerable our oceans are. Oceans cover over 70% of the Earth's surface and produce more than half of the oxygen we breathe. They regulate the climate, provide food for billions of people, and host an unimaginable diversity of life. Yet we often treat them like an endless dumping ground. Plastic pollutes even the most remote corners. Overfishing empties the seas. Chemical pollution poisons marine ecosystems. The Bermuda Triangle, with all its scientific fascination and cultural significance, represents all the oceans of this world. It invites us to look closer, to learn more, to understand deeper, and it calls on us to take responsibility for the only planet we have. As you slowly drift off to sleep, imagine the waves of the Atlantic gently rolling against the shores of the Bermuda Triangle. Imagine life pulsing in all colors and forms beneath the surface. Think of the stories this sea could tell, of adventures and tragedies, of discoveries and mysteries. But also remember that this sea, like all the seas of this earth, needs our protection. The future of the oceans is in our hands. Every decision we make, what we consume, how we travel, how we use resources, has an impact on these vast blue expanses. Science has given us the tools to understand the oceans. Now we must find the wisdom to protect them. The Bermuda Triangle may not possess supernatural forces, but it possesses something far more valuable. It is part of the living system of our Earth, a system that, in its complexity and beauty, surpasses any mystery. Let these thoughts drift with you into the night as you peacefully fall asleep, knowing that our planet is full of wonders. Wonders to be preserved for all generations to come. Good night and sleep well on your journey through the forgotten worlds of our wonderful Earth.